Good morning, Ben Cohn. Wanted to wrap up this calculus course with a few review problems. So without further ado, let's jump in. So we have a funnel. Inside of a funnel of height 10 inches, 10 inches, has circular cross sections as shown in the figure above. At height h, the radius of the funnel is given by r equals 1 over 20, 3 plus h squared. Okay? Where 0 is less than h less than 10. Yes. Units of r and h are in inches. Find the average volume of the radius of the funnel. Okay. So, the way I'm going to do this then is I'm going to write out, so we need to find the average radius. So we'll find the radius from 0 to 10, and the radius is 1 over 20, 3 plus h squared, do dh, and then we'll divide it by 10. That way it'll find the average from 0 to 10. Yep. And just in case you're curious, what we're really doing here is 1 over 10 minus 0. So you have your limits of integration, and we're going by the limits of integration here. Okay, so to solve this, I am going to split this up into 3 dh plus h squared dh. Integral equals 1 over 200 3h plus h cubed over 3. I guess I really didn't need to split that up, did I? It's okay. 1 over 200. Probably should have a big parentheses there. And I'm going to ignore the zeros because 3 times 0 will be 0. And 0 cubed will also be 0. So we will have 30 plus 1,000, because that's 10 to the third, over 3. Change colors to add emphasis. This will then become 90 over 3, which gives us 1090 over 600. And we could probably reduce that just a little bit to 109 over 60. You might be able to reduce that a little bit more, but I am happy with that. And then this will of course be inches. So what we did here to find the average radius, they said average radius? Average value of the radius. So we took the integral from 0 to 10, basically the whole range of the radius, and then divided by the length or the values that we integrated over. So in this case it was 1 over 10 because it started from 0, went to 10, 10 minus 0 is 10. That gives you the average radius. Okay, find the volume of the funnel. Okay, so for this, we are going to use the disk method. So the disk method is, the idea here is, break these up into little disks. These disks will be delta h's, and therefore the volume will be from 0 to 10 of pi r squared, because pi r squared is the area of a circle, and then the delta h will give it a volume. We know that we have, put a pi in there, and the integral, we'll do 3 plus h squared dh. Now, we need to be careful here. We can't just multiply the 3 and the h squared. We need to FOIL it. So we'll have 9 plus 6h squared plus h to the 4th, which is no big deal. dh, come down here, pi over 20 9h plus 6h cubed over 3, because your exponent goes up by 1 and then you divide by what you what your exponent became, plus h to the 5th over 5, and then this will be from 0 to 10. Okay, writing this out a little bit more, we got pi over 20, 90, plus 6,000 over 3, plus 5, 1, 2, 3, 4, 5. There we go, 1, 2, 3, 4, 5. Okay, and that's what, 1, 2, 3, 100,000? Okay. Simplifying life slightly, we'll go with 90. Okay, still got 90. 90 plus 2,000 plus 20,000. Take off a 0. And we're left with 2209 over 2 pi. Yeah, that worked out pretty well. And this will then be inches cubed. Wonder where that 20... See that 20 there? That should be squared as well. Outrageous. So go through all this again. And then there should be another 20 right here. So we'll change this 20 to 40. I'm not quite sure how to simplify that, so I'm going to leave that as is. 2209 over 40, not 20, because that 1 over 20 has to be squared as well. And then inches cubed. There we go. Move the equal sign a little bit closer. That way it's easier to capture. Whoop, move over here. Clean up the board. There we go. Oh, forgot the little teeny piece right there. All right, so let's go for number C. So you only have about 15 minutes for these problems, which looks like I'm going at a reasonable pace. Normally I'm pretty slow on these, but some of these free response problems, they can really throw you for a loop. So some are much more difficult than others. So even though you have 15 minutes for one, if you can move through one expeditiously and have a few minutes left over, that's greatly preferable. Save up all your time for a rainy day, so to speak. Though the last question could be terrible and I could be completely lost. Funnel contains a liquid, okay, that is draining from the bottom. At the instant when the height of the liquid is h equals 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inches per second. Okay? At this instant, what is the rate of change of the height of the liquid with respect to time? Okay. So I have no idea what that said. But I know that said, I knew a lot of the parts that it said, and it says that, let's see here. The radius of the surface of the liquid is decreasing by 1/5 rate per second. So we know that R equals 1 over 20, 3 plus h squared. And therefore we can say that dr dt equals 1 over 20. 3 just goes away. And then we have 2h. And I'm going to put in dh dt, where dh dt is, so we use the chain rule here. Dh dt is the change in height with respect to time. So, and they said something about, at the instant the height of the liquid is 3 inches. Okay, so they gave us h. Oh, that wasn't meant to cross it out. That was meant to underscore. Underscore. There we go. And they want us to find the height of the liquid, the rate of change of the height of the liquid. Okay, so they actually want us to find dh dt. So rearranging this equation, give it a blue. dh dt equals dr dt times 20 times 1 over 2h. Move the 2h down, 1 over 20 over, okay? And they say that dr dt, this equals 1/5. Okay, I'll go with 1/5. 20 is just 20. 1 is 1. And h is 3. Whoop, right there. So simplifying this, we have this becomes 4. This becomes 1 over 6. I think there's supposed to be a negative. Yep, decreasing. This is supposed to be a negative. There we go. This becomes negative 2/3 inches per second. Whoop, bam, right there. That wasn't too bad. You even felt reasonably confident about that. So they give us a funnel. They said find the average volume value of the radius. So we found all the values of the radius using an integral, and we divided by the length that we took the radius over, the limits of integration. Then to find the volume of the funnel, we use the disk method, and then to start at the bottom, go to the top, 0 to 10, make little disks. The disk is pi r squared. Therefore, you have to do the radius, which you're given, squared. And then they tell us that the base just gives a whole bunch of information. And they're like, all right, here's a rate of change, there's a rate of change. And we're like, well, not really quite sure what to do. So we take the one formula we have, and we take one small piece of information that they give us, like, find dr dt. It's like, oh, we have r, let's find dr dt. And part of that, using the chain rule, is we're going to get dh dt, change in height with respect to time. And from that, then, we can find what they wanted us, which was the height of the liquid, the rate of change of the height of the liquid with respect to time. That wasn't too bad. Very nice. Very accomplished. Okay. Clean up the board briefly. And grab the next one. Alright. So for this one, the function f has a Taylor series. Our dear friend, the Taylor series. Taylor series are using derivatives to approximate a function. You should know that. About x equals 1. Okay? I think that means that a equals 1. So when we write out the Taylor series, we have an a, which is what we do the Taylor series about. And that means that a equals 1. That converges to f of x for all x in the interval of convergence. Okay? It is known that f of 1 equals 1, f prime of 1 equals negative 1/2, and the nth derivative is given by this formula here. Okay? For n greater than or equal to 2. Write the first 4 non-zero terms of the Taylor polynomial. Okay? So first thing I would do is I would write out the formula for the Taylor polynomial. So it's something like summation of f to the n of a times x minus a to the n over n factorial. And what they do then, so this is the derivative. So the 0th derivative would just be f of x. So writing this out then, we know that the first derivative is 1. And then they also, when they said about 1, this is that's what that a equals 1. Yep. So f of 1 is 1. X minus a, which is x minus 1 to the 0 over 0 factorial. So this is going to be 1, and that's going to be 1 as well. Then we will do minus 1/2. Let's do 1 over 2 times x minus 1, the first, all over 1 factorial. Both 1 factorial and 0 factorial are 1. Now we have to use this formula. So this would be n equals 2. This will be n equals 3. So with n equals 2, negative 1 squared is 1. So it looks like it's going to be kind of an alternating series. Then we're going to have, this is just for the first derivative part, that number right there. So 2 minus 1 factorial will be 1 factorial. Yep. All over 2 squared. Then we'll have x minus 1 squared all over 2 factorial. Okay, then we get to negative 1 to the third, which will be negative 1, times n minus 1 factorial, which will be 2 factorial, which will just be 2, all over 2 to the n, which will be 2 to the third, times x minus 1 to the third, all over 3 factorial. Okay, so these are the first 4 terms. We want the first 4 non-zero terms. It only goes up to n equals 3 because n equals 0 counts as a term. And so now they probably want us to simplify these a little bit. It'd be sort of rude just to leave it as such. Okay, so this is 1 times 1 divided by 1, which is 1, minus 1/2 times x minus 1 plus, okay, so now we look at this one, 1 times x minus 1 squared, x minus 1 squared, all over, let's check that again. So it looks like we're going to have n minus 1 factorial over 2 to the n, yep, over 2 factorial, okay? So we're going to have 2 squared times 2 minus, and then we come over here, we look at, we have 2 factorial and 3 factorial, so if we cancel that out, that gives us 3. So we're going to have x minus 1 cubed over 2 cubed times 3. So it's going to look like what we're going to have here is, we'll get something where we'll get 2 to the n, and then here we'll get, right there we'll get n. And here we didn't see that because it's probably 2 over 1. So they just left the 1 out when they gave us the factor. Okay, so that's part 1, part A, part alpha, part B. And normally I'd erase that, but I'm going to leave it up here because I'm never quite sure what I'm going to need for the next parts of the Taylor series. Delicious. Okay, the Taylor series for f about x equals 1 has a radius of convergence of 2. Okay? Okay. Find the interval of convergence. Show the work that leads to your answer. Okay, so we have, it's around about, we are finding this Taylor polynomial about a equals 1 with a radius of 2. So it means we're going to go from negative 1 to 3, and we're going to, it'll work within those points, but we don't know if it'll work at the end points. And so we want to test the end points to see if those work or not. So what we're going to do is we're going to take this thing right here. I'm going to write it out. So we have, let's do it this way, negative 1 to the n minus 1 factorial 2 to the n, and that gives us the derivative, and then we're going to want to do x minus a to the n all over 2 to the n, as we discovered down here, times n. And what they're saying is a can be, what they're trying to see what a can be here. So what we're going to do is I'm going to take this, I'm going to copy it twice, pow, pow, and I'm going to put in either -1 or 3. So we put in -1, plus, plus. No, sorry, I'm going about that wrong. What they're saying is that a, or x, is, x can be between -1 and 3. So if x here, so we'll leave -1 here as the a, and we'll have -3, nope, +3, -1. So that value goes there, that value goes there. And what we're going to see, because this is the radius of convergence, we want to see if these converge. And so what this becomes -2 to the n. So right here, this becomes -2 to the n, which equals -1 to the n, 2 to the n. So you get the 2 to the n, that cancels. The -1 to the n, that'll cancel this other -1 to the n. This n minus 1 factorial will cancel with this n factorial. Yep, this is supposed to be n factorial down here. That will cancel with the n factorial to give you n. And then I had this, add an extra 2 to the n there. Should have been there. Man, I'm making all sorts of mistakes. So what you're left with then is, in this case, you're left with 1 over n. And in this case over here, we have 3 minus 1 to the n, which becomes 2 to the n, which those cancel. And here we're left with -1 to the n over n. So I did not show that as clearly as I should have. So when they say radius of convergence, for about x equals 1 has radius of convergence of 2. So x converges within 2 of 1. So x can be from -1 to 3. But the question then becomes with the endpoints. The endpoints are always kind of fuzzy. And so what we want to do is we want to test the endpoints for x. And so when we broke this part down up here, where we said that the formula we're going to have for the general term, did they ask us to find the general term? And the general term. Oh, we need to find the general term. So general term equals, so this is going to be x minus 1 to the n over 2 to the n times n times -1 to the n, because it's alternating. Okay, so this is the general term. We take the general term, we go down here and we plug in -1 for x, we plug in 3 for x, and then we simplify it. And it simplifies down to the harmonic series for -1, and it simplifies down to the alternating harmonic series for 3. And the alternating harmonic series does converge, because for an alternating series to converge, it needs to alternate. You have your -1 to the n, but then it also has to go to 0, which it does. This one, the harmonic series, 1 over n, goes to 0, but it doesn't alternate, so it diverges. So -1 will not be in the radius of convergence. So the radius of convergence will be -1, where -1, 3, where -1 is not included, but 3 is included. That's what the little bracket means versus the parentheses. So this will be the answer to number B. Oh man, that's a lot of work for just 2 problems. 2 parts. Okay, so that's the idea behind part B. Now part C, the Taylor series for f about x equals 1 can be used to represent f of 1.2. Yes, because 1.2 is between -1, non-inclusive, and 3, included. As an alternating series, use the first 3 non-zero terms. Okay, that's good because we already have the 3 and then the 4th one here. 3 here and then the 4th one there. To approximate f of 1.2. Okay, so this, easy, maybe. Okay, so f of 1.2 is approximately 1 minus 1/2 times 1 minus 1.2. Nope. 1.2 minus 1, there we go, plus 1.2 minus 1 squared over 2 squared times 2. And this is the first 3 terms. Yes. So then we'd have 1 minus 0.2 over 2 plus 0.2 squared all over 2 times 2 times 2. Simplifying a little bit, we have 1 minus 2 over 10 times 2 plus 2 squared, 1 over 100, that's the point part squared, times 1 over 2. When I write things this way, it makes it easy to cancel. Cancel. 1 minus 1/10. I'm going to write that as 0.1. 0.1 plus 1 over 200. Yeah. 1 over 200 is 0.005. 0.01 is 1 of 100. Yep, okay. So we have 0.905. There we go. Bam. Which is approximately f of 1.2. Okay? Excellent. Here's the first 3, now 0. Okay. So the approximation found in part C is within 0.001 of the exact value of f of 1.2. Okay. So this is why we only use the first 3 terms, because they wanted to set us up to be able to solve. So the idea behind an alternating series is you have an approximation that keeps getting closer and closer to the right answer. So the margin of error for an alternating series, actually for any series, I think for any Taylor series, will be within the following term. So we want to find the value of this term right here, and that will show us the margin of error we have. So if we take this term right here, copy, paste, I get rid of this. Nope. Just rid of this. There we go. Move this guy up here so he's not so lonely. I'll draw some arrows. Yep. So we have 1.2 minus 1 cubed over 2 cubed times 3 equals 2. So 0.2 cubed would be 2 cubed over 10 cubed, which is 1,000, times 1 over 8, which is 2 cubed, times 1 over 3, cancel, cancel, equals 1 over 3,000. So what this tells us, and the value they had was 0.001, that's 1 over 1,000. 1 over 1,000. So what we have here then, we've shown, therefore, the error is less than 1,000 because the fourth term shows an error less than 1 over 3,000. Bow. Yes. Okay. So those are a couple problems to kind of wrap up the idea of what we're doing here. So this is the end of my Calculus BC course. Still should practice problems. I got lots of other practice problems on my channel, on my website. But this is all the knowledge you need to know for the AP BC Calculus exam. So from this point on, just practice, get yourself ready, take the test, pass, and win. I appreciate you guys sticking along. Wish you guys to come over and watch some of my other videos. Got lots of physics videos as well. So thank you much. I appreciate it. Take care. See you next time.